The machines used by the machinist are called machine tools. Thousands of things we use every day are made with them. Or they are used in making other machines that make bicycles, electric motors, gasoline engines, in fact, most of the necessities and comforts of our modern lives. Although machine tools work on metals, they have a familiar cousin in a familiar machine, the woodworking lathe. The basic features of the design and of the operation of the woodworking lathe in the home or school shop are much the same as lathes used for machining metal. In addition, the woodworking lathe does with wood what some machine tools do with metal. It also demonstrates one of the 5 basic ways in which metal is formed by the machinist. On this engine lathe, the machinist is producing a cylinder from a steel bar. In much the same manner, our home craftsman was with the wooden cylinder in his woodworking lathe. This fundamental method of machining metal is called turning. In this case, a perfect cylinder of exact diameter is being made by the machinist. The tool that cuts this steel bar acts in much the same way as the chisel did in cutting the wood in the woodworking lathe. The drill press demonstrates a second way in which metal is machined. It is a simple machine tool in which a drill produces a hole in a piece of steel. In addition to drill presses, the engine lathe and other more complicated machines are also used to produce holes of all sizes in metal. A milling machine sometimes is used to produce flat surfaces. This third method of machining metal is called milling. In addition to producing flat surfaces, milling machines also are used to cut gear teeth. A machine tool called a shaper may be used when surfaces are to be made flat. This fourth way of working metal is called planing. In the shaper, the work is stationary. On another machine, called the planer, the tool is stationary while the work is moved back and forth. Grinding is the 5th way to machine metal. There are many kinds of grinding machines and many types of grinding operations. Through the use of an abrasive wheel, a flat or even a round surface of extremely smooth finish and of great accuracy may be produced. No matter where he works in the shop, the machinist must know how to read blueprints. They show him the shape of the machine part or other article he is to make, and its exact dimensions. And in order to be sure that whatever he is making corresponds to the blueprint, the machinist must measure it with tools, such as these outside calipers. He must learn to use them skillfully and accurately. Some measuring tools are simple, or they may be more complicated, like the micrometer. Skill 1,000. One of the introductions to shop work for the beginner is bench work. Filing metal to size, for example, is out of skill that can be learned through practice. Scraping is another type of bench work. To learn this hand operation, long practice and great skill is required, because extremely accurate surfaces, especially on machine parts, may be produced in this manner. Beginners in the machinist trade usually start work on a production job, where they do the same type of work each day. If they work on an automatic machine, little skill is required. On semi-automatic machines, like this turret lathe, more skill is required of the operator. He must know something of the tools he is employing and of their function and operation in order to operate his machine properly. He may even have to measure his work to check on its accuracy. When he learns how to set up work in the machines he is operating, the student machinist may be promoted to the position of setup man or line foreman and set up work in the machines for the less experienced operators. A more advanced type of setup man and machinist is one who can set up jobs in several types of machines, or who is qualified to operate several different kinds of machines. He is a general machinist. When he becomes skilled in the operation of all types of machines, knows their parts and how they operate, the machinist who works constantly to better himself may become a maintenance man. The maintenance man in the large shop not only keeps machines in perfect mechanical condition through routine repairs, but he may also make parts for the machines in his care. This requires skill just a step short of the toolmaker. Highly specialized machines are developed for use in many large industrial plants, usually to do one particular job or type of work. Some are enormous, and others are of ordinary size. Some require a high degree of skill to operate, and others may be entirely automatic. Many of them present complicated work for setup and maintenance men. The toolmaker is a highly skilled and experienced machinist. He may work within 1/1000th of an inch, a space no bigger than a hair, in making the original samples of a new job his shop is to produce, or in making precision tools that the machinists of his shop will use in producing some large-scale production job. Toolmakers may work in either the small job shop or they may have the best-paying jobs of the biggest shops. Skill in all phases of the machinist's craft plus experience are necessary before one can become a toolmaker. Closely akin to the toolmaker in skill and in precise work is the die maker. Frequently, the same man who makes tools will make dies, for in both jobs, ability to work accurately and precisely is essential. Long training and experience lie behind both the toolmaker and the die maker. The experienced tool or die maker who gains a full and complete knowledge of his trade and of machines may become a tool designer. Knowledge of machine principles and of higher mathematics are necessary in designing machine parts, tools, and jigs. The small job shop offers an opportunity to gain experience with various types of machines, to learn the fundamentals of the machinist's craft. Or one can begin as a helper to an experienced machinist in a larger shop. It is in this manner that many apprentices in big manufacturing plants begin. In addition to their work in the plant at machines, apprentices attend classes in mathematics, machine design, and science. School machine shops offer another opportunity for learning the machinist's trade. If you learn decimals and simple arithmetic in the classroom, if you like to work with your hands, if you like to make things, if you are not afraid of oil, grease, and dirt, if you like machinery, you can become a machinist. With that simple background, you can obtain a fairly good job. Day or night trade schools, either public or the reliable private trade schools, offer a sound background in machine shop practice. This is supplemented by classes in mechanical drawing and the simple arithmetic of fractions and their equivalents that will enable one to become a skilled machinist. The school drafting room will teach you to read blueprints, something you must know, especially if you want to become a designer. The designer must know higher mathematics, and the toolmaker must know something of how they apply to his work. And both must keep abreast of every new development in machine practice and machine design. If you can develop your manual and mental skills to do a job accurately and well with a machine tool, If you want to learn and are ready to start at the bottom, if you're not afraid of hard work, then the machinist trade offers you opportunity for your life work.